Hi, Year 9 students. I'm Norman Wildberger. Today we're going to do a little bit more review on decimal numbers now. We'll have two lectures on decimal numbers. This first one is going to introduce the basic framework, and then the one after will connect more with fractions. So decimals are very important for practical use. Most scientists, engineers, economists will use decimal numbers when making calculations, when estimating quantities. And so it's very important that we get to be familiar with decimal numbers, and they'll also come up in the Year 9 curriculum. We're going to be talking about scientific notation, which is very much based on decimal numbers, and a lot of statistics naturally uses decimal numbers too. Okay, so decimal numbers, you can think of them as being an alternative to fractions when we're measuring something. In other words, it's another way of thinking about the points on the number line. And it's pretty closely connected with the idea of fractions, but there's important differences. Roughly, we can say that the idea of decimals is that we're going to subdivide by 10. With fractions, we were able to divide by pretty well anything we wanted to. We could divide the interval into 3 equal pieces, or 7 equal pieces, or 29 equal pieces. With decimal number arithmetic, we're always trying to divide by 10, because that corresponds to the Hindu-Arabic system that we use, which is all based on powers of 10. Of course, ultimately comes down to the fact that we have 10 fingers. Okay, so here is our familiar number line. And this time I've divided each of the basic intervals into exactly 10 pieces. Okay. So there's 10 subdivisions there. And okay, it's a little bit too crowded to give them all names, but in terms of fractions, these points would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, and so on. Okay, now what we're going to do is we're going to introduce an alternative way of thinking about those particular kinds of fractions. So the starting point is 1/10. We're going to think about 1/10 as being represented by 0.1. And then 2/10 will be represented by 0.2, 3/10 by 0.3, and so on. 7/10 by 0.7. When we get to something like 2 and 4/10, which will be out here, we're going to replace the 4/10 with a 0.4 and just write 2.4. Similarly, 4 and 9/10, which would be out here, is going to be represented by 4.9. So this number that's appearing after the decimal point is the number of tenths that we're adding to the normal number, which is to the left of the decimal point. To the left of the decimal point we have an integer, and to the right of the decimal point we have a certain number of tenths so far. We can also talk about negative numbers. So if we go over here, this is the fraction minus 8 over 10. Its decimal will be minus 0.8. And so we're going to get this decimal number scale where we divided each of the intervals by 10. And we're then going to extend this Hindu-Arabic number system that we're very familiar with, involving ones, tens, and hundreds. We're going to extend that by introducing a decimal point to the right and at the bottom of the ordinary number, and then the next number is going to represent the number of 1/10. That's kind of a new unit that we're introducing to augment the ones, tens, hundreds, thousands, 10,000s, 100,000s, and so on that we generally use for our ordinary Hindu-Arabic representation of numbers. So 217.8 is just another way of writing 217 and 8/10. So these are the simplest kind of decimals. So with these simple decimals, we can do some basic arithmetic. Let's have a look at addition and subtraction with these numbers. So in our first example, we're adding 31.4 to 26.2. And I remind you that 31.4 really means 31 and 4/10, And 26.2 really means 26 and 2/10. And here I've done the calculation very much the same way you would just add ordinary integers, except that there's a decimal point here, and we're lining up the decimal point so that it's on top of each other. And then the 4 and the 2 add to 6, the 1 and the 6 add to 7, and the 3 and the 2 add to 5, and we end up with 57.6. And that's the same thing that we could figure out on this side. If we add the integers, we'd get 57. If we add the 4 over 10 with the 2 over 10, we would get 6 over 10. And that's the same. Here's another example with a bit of carrying, making it a little bit more complicated. So we're adding 438.7 to 194.6. When we add the 7 and the 6, we get 13. There's a 3 with a carrying a 1. And then 8 plus 4 is 12, plus the 1 is 13, so we write a 3 and carry a 1. 3 plus 9 is 12, plus 1 is another 13 and carry a 1. And then we get 6. So we're adding ones, tens, hundreds, just as we usually do. But the only difference is that now we also have the 1/10ths column. So we have to include those two. And we proceed from the right, working our way to the left, just as we do when we're adding ordinary integers. And here would be the corresponding fractions over here in more standard form. So over here you see that when we're adding these two integers, we get 632, and when we're adding 7/10 and 6/10, we're getting 13/10, which we could then convert to 3/10 by adding 10/10 to the 2. That's just like how carrying looks like at the level of fractions. Here's a subtraction. 154.6 minus 72.1, and it's the same kind of story. 6 minus 1 is 5, 4 minus 2 is 2, 15 minus 7 is 8. There's the corresponding result in fractions. Let's do a little bit more complicated one where we have to do some carrying. So 438.2 minus 196.9, let's say. So we're going to start on the right hand side. There's 2 here and 9 here, so we have to borrow 10 of them from the previous position. So we now have 12 in the 1/10 slot up here, and when we subtract 9, we'll have 3. The decimal point is lined up with the decimal points of the other two. In the ones column, we had 8 before, but now we only have 7 because one of them was used to add 1/10 to that side. So now we have 7 minus 6, that's just 1. And then 3 in the 10th column, 3 minus 9 doesn't quite work, so we have to borrow 10 from the 100th column, giving us 13 minus 9 is 4. And then in the hundreds, 3 minus 1 is 2, for an answer of 241.3. And in the world of fractions, we could have sort of proceeded in a similar kind of way. If we were going to subtract these fractions, 438 and 2/10 minus 196 and 9/10, what we would probably want to do is we want to make this 10/12 into a 12/10 by borrowing 1. So we take a 1 from the ones column here, reduce the 8 to the 7, and that makes those 2/10 into 12/10. So we're really doing the same thing here, but just at the level of fractions. That would be 12 minus 9 is 3/10, and then over here we had 7 minus 6 is 1, and then we would proceed in the usual fashion. 13 over 9 is 4, 3 minus 1 is 2. So the moral is that for this simple kind of multiplication and subtraction anyway, it looks like decimal number arithmetic is very much the same way as arithmetic with integers, except that we need to keep track of the decimal point. We want to line them up so that always the ones columns are lined up, the tens columns are lined up, the 1/10 columns are lined up, and so on. Now we want to go a little bit further than just having one decimal point. And to understand what those various positions mean, probably the best thing to think about is money. So if you're going to explain decimal number arithmetic to someone, maybe your younger brother or sister, money is probably a best place to start. So let's think of a system where all the units of the money are in powers of 10. Let's say like in dollars. So in terms of money, there's maybe $1 bills and $10 bills, $100 bills, $1,000 bills. Let's ignore 5 and 10 and all the other multiples. Just think about the powers of 10. All right. So that's a collection of bills. And then for smaller quantities, we would have coins which represent smaller denominations than the dollar. For example, we might have a coin that is 1/10 of a dollar. In America, that would be called a dime. All right. So think of 1/10 as a coin. And then another coin, which is 1/10 the value of a dime, or 1/100th the value of a dollar. That would be called a penny or a cent in most places. And most countries these days don't have further subdivisions because a penny or a cent is already very small. In Australia, we don't have any cents anymore. These days, 10 cents is pretty well the smallest thing that you find floating around usually. And but theoretically, at least, you could imagine a situation where you have a smaller valued coin which is only worth 1/1000th of a dollar. I've only made them bigger here so that I have enough room to fit the denominators on. You can think of these ones as being made of more valuable currency, if you like. Okay, and then the whole thing about money is that there's the possibility of exchange. That 10 $1 bills is the same as a $10 bill. They're equivalent. 10 $10 bills is the same as one $100 bill. 10 $100 bills is the same as one $1,000 bill. And the same thing happens over here with the coins. 10 1/10 coins is the same as a dollar. So 10 10-cent pieces would be the same as a dollar. 10 1-cent pieces, or 10 1/100th coins, would be worth one of these ones. And 10 of these ones would be worth one of those. So it's the same pattern all the way around. 10 of these is one of these, 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 and so on. So if you have a certain amount of money, let's say 143.241, what does that mean? Well, it means that you're going to have $100, and the 4 represents 4 $10. The 3 is in the ones column, represents 3 $1 bills. Then this 0.2 would represent 2 10-cent pieces, or 2 1/10th coins. The 4 would represent 4 1/100th coins, which we would say is a 1-cent piece or a penny. And the 1 here represents 1 1,000th coin, of which we don't actually have any in our numerical system, but you could imagine perhaps that there might be such a system. All right, so this represents a certain amount of money. This is the decimal way of writing this collection of bills and coins. And very important, we're thinking of the hundreds column, the tens column, the ones column, the 1/10ths column, the 100ths column, the 1,000ths column. All right, so we're introducing the idea of further decimals, not just 1/10ths, but also 100ths and 1,000ths, and if necessary, we can go further. The next one will be 1/10,000ths. Just as on this side, the next one would be 1/10,000. Right? That's the decimal number system. Rather open-ended on both sides. The possibility of talking about smaller and smaller numbers to the right, or larger and larger numbers on the left. All right, so a general decimal has a form something like this. There's a decimal point somewhere, and to the left of the decimal point is the ones column, the usual ones column, and then to the left of that is the tens column, and then the hundreds column, and then the thousands column, and so on. And to the right of the decimal is the 1/10ths column and then the 100ths column, and then the 1000ths column, and so on. And so this number 0.1, if we don't have any of these and just have a single 1 in the 1/10ths column, that decimal number is the same as the fraction 1 over 10, or 1/10th. If we just have a single 1 in this position, so 0 in this position, 0 in all the other positions, but we represent that 0 by a 0 here so that the decimal's over here, then this number is 1/100th, or 1 over 100. You can see that this 0 is playing the same kind of decimal placeholder as the 0 in 10 is. If you have 10, you have 1 10 and 0 1s. That 0 in the 1s column is a placeholder. If you have 0.001, then we can see from where the decimal is that this 1 is in the 1000ths column. Not in the 1/10ths, not in the 100ths, but in the 1000ths column. So it represents the fraction 1 over 1000. So if we just look at this decimal part, 0.241, that means the 2 is 2 times 0.1. The 4 is 4 times 0.01. And this one is 1 times 0.001. In terms of fractions, this is 2 times 1/10th plus 4 times 100th plus 1 times 1000th. And notice that when we're using bigger fractions, I will generally often write horizontal bar instead of a slanted bar because it sort of looks nicer and it's more efficient. Okay? But you should think of it as being the same thing. And where is this decimal 0.241? Well, here's our number scale. 0, 1, 2, 3. Each interval divided into 10. Okay, into 10. And so between 0 and 1, although you can't really see it perhaps, the positions here are marked 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and that's 1 again. So 0.2 is right there, and 0.3 is the next one. 0.24 is going to be almost halfway between 0.2 and 0.3. We can see where it is a little bit more clearly by taking that interval between 0.2 and 0.3, which is very small there, and blowing it up. So there I've blown it up for you so you can see it better. So we can see that this interval itself is subdivided into 10 pieces here, and each of these 10 pieces corresponds to 100th. Each of these little intervals is 1/10th. Each one of these little intervals is 100th, corresponding to a decimal in the second position. So this is 0.2, then this is 0.21, 0.22, 0.23, 0.24, 0.25, 0.26, 0.27, 0.28, 0.29, 0.3. And then 0.241 is just a little bit to the right of 0.24. It's actually what you would get if you took the interval between 0.24 and 0.25 and subdivided that into 10 equal pieces and took the first of those pieces. That's what the 1 means. We're going to subdivide that interval into 10 pieces. So each one of those would then be 1,000th. And 0.241 would be right that first mark of those 10 that appear there. So each successive decimal to the right is giving you more and more refined, sort of fussy detail as to where things are. It's exactly the opposite of what's occurring when you go to the left. Every position to the left is a bigger and bigger and bigger number and more important. As we go to the right, the numbers are increasingly small and less important. Decimals and fractions give us two somewhat different ways of naming points on the number line. And it's useful to be able to go from one system to the other and back again. Going from a decimal to a fraction is a little bit easier than the other way around. If you have a decimal like 0.241, well, we just have to think, what does that actually mean? The 0.2, this 2 is in the 1/10th position. It refers to 2 over 10. The The 4 is in the 100th position, so it represents 4 over 100. And the 1 is in the 1000th position, so it represents 1 over 1000. So this decimal is really the same as this fraction. And to write that as a fraction in standard form, we would want to get a common denominator. Remember, that's how we add fractions. The common denominator that we should choose here is 1000, because 1000 is a multiple of both of 10 and 100. So we're going to convert all of these things to 1000 and watch what happens. When we multiply top and bottom here by 100, then we get 1000 in the denominator and we get 200 in the numerator. So 2 over 10 is the same as 200 over 1000. When we convert 4 over 100 to something over 1000, we have to multiply top and bottom by 10, giving us 40 over 1000. When we add these things now, because the denominators are now the same, we get 241 over 1000. So if you do that a few times, you can see that it's actually relatively easy. The 241 that's appearing there is just the numerator 241 that's appearing there. And the fact that we're going over 1000 is a reflection of the fact that there are 3 decimals involved here. I also want to point out that what we're calling 0.241 is in many textbooks written as 0.241. Adding the 0 to the left doesn't affect the number at all. It's sometimes used just to make it more clear where the decimal point is, so that there's less possibility of confusion, say confusing that decimal point with a period perhaps. Alright, but generally for us that confusion won't be there, so I'll probably dispense with that. I also should remark that it's possible to add a 0 at the end of the decimal and things don't change. So if we added a 0 to the right here, then that would be like adding 0 over 10,000. And that of course would have no effect at all, because we're just adding 0 over 10,000. So yes, you could put an extra 0 in here and it doesn't affect the number at all in terms of its actual size. So here's some other examples of converting decimals to fractions. 0.36 is the same as 36 over 100. 0.045 is the same as 45 over 1000. 3.4, which is the same as 3 and 4/10, can also be written as 34 over 10. And 54.103 can be written as 54 and 103 1/1000ths. And if we wanted to write that as a composite fraction, we could write it in this fancier way: 54,103 all over 1000. Okay, and as I mentioned before, for larger fractions we'll often replace the a over b with a slanted line with just a horizontal bar b. Here are some examples of going the other way, where we start with a fraction and we go to a decimal. We're not in a position to do that very generally, so we have to choose the fractions rather carefully at this stage to do that. So these fractions are all ones whose denominators are 10 or 100 or 1000. So 7 over 10 is 0.7, 13 over 10 is 1.3, 87 over 100 is 0.87, 3 over 100 is 0.03, 3 over 1000 is 0.003, and 204 over 100 is 2.04. So a natural question is there some sort of easy way of getting these things? And in fact, if you stare at them for a little while, you'll see that there is actually quite a nice easy rule, an easy method for converting this kind of fraction to a decimal. Alright, so very important to understand how to multiply and divide by powers of 10. This is what decimals are ideally suited for, to scaling by powers of 10. Here are the various units that we're using in our decimal number representation. The ones, the tens, the hundreds, the thousands, as well as the 1/10ths, the 100ths, the 1000ths, and so on. And they have the property that if we take any one of them and we multiply it by 10, then we get the next one. If we multiply 1 over 1,000 by 10, we get 1 over 100. Multiply that by 10, we get 1/10th. Multiply this by 10, we get 1. Multiply this by 10, we get 10, and so on. And conversely, dividing by 10 just takes us in the opposite direction. If we divide 1,000 by 10, we get 100. If we divide 100 by 10, we get 10. Divide 10 by 10, we get 1. Divide 1 by 10, we get 1/10th. Divide this by 10, we get a 1/100th. Divide 1/100th by 10, we get 1,000th. Okay, so this multiplication and division by 10 works with other numbers too. So I hope that you all never use a calculator to multiply by 10 or, in fact, by other powers of 10, or divide by 10 either. So if we multiply 2 by 10, we get 20. We multiply 45 by 10, we get 450. Why is that from what we set up here? Well, the 45 is really 4 of these and 5 of those. If we multiply everything by 10, then we get 4 of these and 5 of those. In other words, 450. If we have 0.3 times 10, well, the 0.3 is 3 of those. If we multiply by 10, we're going to get 3 of those. So we get 3. If we have 1.456 times 10, we have 1 of these, 4 of these, 5 of these, and 6 of those. If we multiply by 10, everything moves over to the left. We have 1 of these, 4 of these, 5 of these, and 6 of those. 14.56. In the other direction, if we're dividing by 10, 78 divided by 10. 78 is 7 of those and 8 of those. If we divide by 10, then we have to move this way. We have 7 of these and 8 of those. And that's 7.8. If we have 0.2 divided by 10, 0.2 is 2 of these. Okay? So if we have 2 of these, we divide by 10, we're moving in this direction, we have 2 of these. So 0.02. What about multiplying by 100 or dividing by 100? Well, remember that multiplying by 100 is multiplying by 10 and then multiplying by 10 again, because 10 times 10 is 100. So if you want to multiply by 100, one way of doing it is to multiply by 10 first and then multiply by 10 once more. Well, if we know what multiplication by 10 is, then multiplication by 100 is what you get when you do that twice. So multiplying this by 10 would be here. Multiplying that by 10 would be here. So multiplying by 100 takes this thing to that. In other words, it takes 1/1000th to 1/10th. Takes 1 over 100 to 1. Takes 1/10th to 10. Takes 1 to 100 and 10 to 1,000, and so on. And similarly, dividing by 100 is going to move us over 2 steps. Divide 10,000 by 100, you get 100. Divide 1,000 by 100, you get 10. Divide 100 by 100, you get 1. Divide 10 by 100, you get 1/10th. Divide 1 by 100, you get 1/100th. Divide 1/10th by 100, you get 1,000ths. And so on. And I'm not going to go through it, but you can, I think, convince yourself that if we want to know about multiplication by 1,000, well, that's just going to move us 3 over. Multiplying this by 1,000 gives us 1. Multiplying this by 1,000 gives us 10. Multiplying this by 1,000 gives us 100, and so on. And division is the opposite. It's very important to understand the powers of 10. Multiplying by 10 or 100 or 1,000 or dividing by 10 or 100 or 1,000 is very easy in the decimal system because the units are arranged so that multiplying those units or dividing by those units gives you ones to the left or to the right. So in practice, when you're multiplying or dividing by 10, there are some very simple rules that incorporate this shifting to the left and to the right. So the idea is that instead of moving all the numbers to the left with respect to a fixed decimal point, another way of thinking about that is just to leave the numbers where they are and move the decimal point over to the right. It has exactly the same effect. Alright, so the rule is that when multiplying a decimal by 10, just move the decimal point 1 to the right. So for example, if you're multiplying 3.4 by 10, you just look at this thing and see where the decimal point is. It's right there, and we're going to move it over to the right. So now it's there. 34 point. Well, if there's a decimal to the right of the number, we just usually don't write the decimal. That means it's just an ordinary number. We just write 34. When we divide a decimal by 10, well, the opposite. We move the decimal point 1 to the left. So 0.78 divided by 10 is the decimal point, which is here, has to move to the left. Okay, that's a bit of a problem because there's no number to move there. So in such a situation we have to introduce, there's a 0 sitting here. The 0 doesn't have any effect, but it's a convenient placeholder if we have to move the decimal over to the left. Alright, so 0.78 divided by 10 is 0.078. And just remember that when you're moving the decimal place over to the left, the number is actually getting smaller. And when you're moving the decimal point over to the right, the number is getting bigger. Right? So this corresponds to multiplying by 10, and this kind of movement is dividing by 10. Okay, once we have 10 down, then 100, as we've noticed, is not much different. So when multiplying a decimal by 100, we'll just move the decimal point 2 to the right. Once for the first 10 that you're multiplying by, and then once more for the second 10 that you're multiplying by. And when dividing a decimal by 100, well, then you move the decimal point 2 to the left. So for example, 61 times 100 is 6100. There's really a decimal point there, or right there, and we're moving it over 2. So again, we're sort of introducing some placeholder zeros to the right which don't affect things, but they are very convenient so that the decimal point has some place to go to. And once it gets to there, then we just drop it because we recognize that's just an ordinary number, so we don't need the decimal point sitting there to the right of it. 5.4 times 100. Well, the 5.4, the decimal's there. We move it over once, and then we need to introduce a 0 so that we can move it over once more. And once we've moved it over once more, well, we can drop it because it's just an ordinary number. 3.7 divided by 100. So here is the 3.7. Originally there was a decimal point there. We have to move the decimal over to the left once, twice. Introducing a 0 placeholder so that there's some place where the decimal can go. And 980 divided by 100, here the decimal is right there, although it's not actually visible. When you move it to the left twice, it ends up here, so you get 9.80. And that 0 at the end is extraneous. So zeros at the ends don't affect things, so 9.80 is the same as 9.8. So there's a rough review of things that I hope are very familiar to you with regard to decimal numbers, what they are, how to think about them, where they fit on the number line, converting back and forth between decimals and fractions and some fractions to decimals. Let's have a little bit of practice now. Okay, so let me reemphasize again the importance of you putting your understanding to work, solidifying it by getting it down on paper, by writing something down on a piece of paper. It doesn't have to be on a computer. I'd prefer that you write it on a piece of paper with a pen or a pencil. Alright, so I want you to make these calculations, of course without a calculator. That almost goes without saying for most of the first half of the year of grade 9 anyway. So, convert to a decimal. Here are some fractions. and you get to convert them to decimals. And here are some decimals, and you get to convert them to fractions. And question 3 is to locate the numbers in question 2 on a number line. So draw yourself a number line that goes from, say, -2 to 13, something like that, gives you some room, and just locate these numbers. It may be approximately, but I want you to have an understanding of where the numbers are. Okay? We want to always anchor our understanding to the number line here in Year 9. And here are some computations to make. 1.2 plus 3.46, so an addition, subtraction, division by 100, a little combination of multiplying by 10 and subtracting, combination of division and addition. There's a combination of a division and a multiplication. And hopefully the answers that you get to this question 4 will be amongst these ones. So please have a go, practice. Okay, in our next video, which is going to be the last of our review videos before we actually start the Year 9 curriculum proper, we're going to finish off this section on decimal numbers. Okay, there's more to be said about decimal numbers. We want to talk about multiplication of decimal numbers, which is a little bit trickier, and division of decimal numbers, which is even trickier. And then we want to make sure that we have more of a sense of the correspondence between decimals and fractions. What happens if you have a fraction whose denominator is not 10 or 100 and you want to convert it to a decimal? What happens there? That's an important kind of question. All right. So still quite important, but with that as the basis, these 5 videos then will give you a solid summary of the things that hopefully you will have learned sort of before you're moving into grade 9. If you have a good understanding of these things, then grade 9 mathematics will be a piece of cake for you. All right. So next time we're going to be doing final review of decimal number arithmetic. I hope you'll join me for that. I'm Norman Wildberger, and I'll see you next time.